Welcome back, everybody. It's your favorite professor, Dr. T. So I'm going to use some of these notes that I had. These are like learning guides. I don't need to go over every single problem, so I'm going to just go over, on the left side, you can see there's an example, and then on the right side, there's a problem that you could work out. And these are located in D2L. Pretty much understand how to graph linear functions. This is an absolute value function on the left where it says 2b. So you just plug numbers in and you just evaluate. So that is how you figure out how to graph. You have your inputs, your x values, and then you have the process, which is here in the middle, and then you have your coordinates that you just plot, and then you just, I think about it like connecting dot to dot. The number 3, that's just changing the window so that you can, when you view your graph, you change it based on, the window. That's like kind of like how when I showed you zoom in, you would just change the window. You can do that on Desmos too. So let me just type here, y equals the absolute value of x. I think it was x plus 1, something like that. And then, so you see how you see everything is counting by 2s? Well, you can change it so that you can see every number on the number line, and you can even go in deeper. Sorry, this is being weird. So you can go in deeper and see, every single tick mark. But I think there's a way to change the viewing rectangle here. So if you look here where it says x-axis, it's going from negative 6.2 something to 5.867, whatever. And then the y-axis also. So that's just what that problem is talking about. And then we went over x and y intercepts in the zoom. So you already know what they are. Identifying x and y intercepts where it crosses. The x-axis is the x-intercept, and where it crosses the y-axis is the y-intercept. This is just a depiction of what the linear function really would represent in real life. There's all kinds of scenarios where you can model situations with linear functions. Most places would use these for, research. You can use some of it in science, data, and sales. All right, so the formula here is used to determine the marriages ending in divorce after 15 years when a wife is under 18 at the time of marriage. But you just plug in your numbers to your function and you just figure that out. Use the appropriate line graph to determine the percentage of marriages. And so you just would locate 15 on the horizontal axis and locate the point above it on the graph. Read across to the corresponding percentage. That's just the y-axis. And the percentage is 60. That is from this problem here. So if you go up to 15, under 18. So if you go to 15 and you go up to this dot, then the corresponding percent is here. And then there's just a follow-up question. Does the value of the model underestimate or overestimate the value shown by the graph, and by how much? So this is the value given by the model, 65%, is greater than the value shown. Okay, so for section 2 in chapter 1, you should be pretty good with solving equations. That's just a review. All of that's review. If you look on the left side, it's a lot of work, but when you're solving problems that have fractions, you just need to find a common denominator. So for this one, it would be, so the common denominator is 24. So you just divide everything that's in the denominator into 24. So with 6, it's 4. So it's 4 times x plus 3. And then that's equal to, what's 24 divided by 3 is 3. So that's 3 times 3 here. And then for 4, it would be 6. So I get 6 when I divide 4 into 24. So it's 6 times x minus 5. So you just have to be careful, making sure that you multiply the remainder after you divide to the entire quantity. So this would be 4x plus 12 equals 9 equals 6. Nope, not equals. Go back. Plus 6x minus 30. And then you just solve it like a regular equation. And you're done. All of the denominator goes away. So, well, if I bring the 6x over, I'm going to get negative 2x, which I don't really like. But on the other side, I need to subtract 12 and then leave everything else the same. So I subtracted from the left side and I end up with negative 2x. And this will be 9 minus 12 would be negative 3. We get a fraction? Let me look. Yep, we get a fraction. So x is equal to 33 over 2. It's just an odd answer. All right. Same thing for here. It's just that when you have variables in your denominator, you just need to do the same thing. So the common denominator would be 2x. And again, you have these in D2L, so you can look at them on your own, the example parts. So this would be x into 2x is 2, so this would be 2 times 4, and then 2x into 2x is 1, so we don't multiply anything to the 5. And then 3 out here needs a denominator, so you multiply that by 2x, so this will be 8 equals a 5 plus 6x. Subtract 5. And we get 3 equals 6x. I can rewrite it as 6x equals 3, and then x is equal to 1/2. It's the same process here. I'll let you try that one. So if you feel like you have trouble with one that has an expression in the denominator, write all of this down and then try the problem. Okay, remember they are in D2L. Same thing here. It's just conditional because -7 does not equal 1. So the solution set is empty, meaning it's just not there. Inconsistent. When you have an identity, so here you see that 9 is equal to 9. So the solution set is a real number, which is denoted here. And then this is just an application of the same type of problem. They give you a low humor group, they give you a high humor group, and then you just find your solution. I'll let you spend time on this one as well. You're just setting up equations based on situations. Just follow the examples. These sometimes give students trouble because you're not solving for a number, you're actually solving for a variable. So, and remember this is section 1.3. So it says solve each formula for the specified variable. So they tell you which variable they need you to solve for. So for this one, you're solving for P. So we just need to use algebra, right? So we would subtract D from both sides. And then we would divide everything by, we would divide everything by M. So P is equal to T minus D all over M. Same thing for the next one. It says we are solving for I. So the first thing you would do is divide I out. And then you just divide everything by what's next to I. So E is equal to big R plus little r. And the nice thing is you have those down there. Section 1.4, I did not spend a lot of time on this, and I'm not sure how much time was spent in your previous course on complex numbers. But I'm not sure how much time was spent on complex numbers, but it's just like adding like terms. So this would be 8 minus 2i. And it is a good idea to write it in the proper form, a plus bi. So the plus does not mean that your result is going to end up with a plus, but you're always adding in algebra. So just keep that in mind, that even when you have a plus, it could be a negative number. So you might be adding a negative number to something. And then when you subtract, you just need to be careful that you distribute this negative to both terms inside the parentheses. So 3 plus 2i minus 5 plus 7i. Just be careful with that. So you end up with negative 2 plus 9i. I'm pretty sure you all already know that I squared is equal to negative 1. So be careful about that. And then as you see with the example here, you just use the FOIL method. So we would have negative 15 minus 5i plus 12i plus 4i squared. And when I did these, I just automatically put the negative 1 in there and multiplied it. So negative 15 plus 7i minus 4. So you end up with negative 19 plus 7i. And then the next one you just distribute. So if you want to practice that one, you can. I'm going to do one that is a little bit more challenging. So hopefully you know by now that you cannot take a square root of a negative number. It is an imaginary number. So the square root of negative 1 is actually I. So if you have something that doesn't have a perfect square root, as you see here on the left, then you have to break it up into something that can be taken a square root of, and then you may have something remaining underneath the radical. So over here, it's not that bad because it's perfect. So the square root of negative 64 is 8i, and then you subtract the square root of negative 25, which is 5i. So you end up with 3i. Okay, so when you are multiplying, well, you see the square here. Oops, you see the square. So that means you're just going to write this twice. Oops, negative. And then the first, which would be 9, outside, which would be positive, right? Because this multiplied times this would make it plus, but then there's I outside, right? So we'll just put 3i. So 3i square root 7 plus 3i square root 7. And then when you multiply these two, it's going to be, I'll just write it out. So it's plus, and then there'll be an I squared times 7. So that'd be multiplied. So when you have, so if you look at the example over here, it's the same thing here, right? And notice what you end up with when you multiply the last two terms together. Okay, they didn't write it out like I did on this side right here. They didn't write out both quantities like I did here and here. But notice what you get when you multiply two radicals together. So just remember that the square root of x is equal to x to the 1/2 power. So if I multiply two radicals together and they have the same base, this is x to the 1/2 plus 1/2. Okay? And 1/2 plus 1/2 is x to the first power. And so that is how the radicals end up going away. So this is going to change to -7 because I squared, let me write it down here, I squared is equal to -1. So this will be 9, right? And then it'll be plus 6i square root 7. So this should be, let me just make sure, I just want to look at the end result. Yes, so it's going to be 2 plus 6i square root 7. And that is your result. And then here, we just need to separate. So we'll have -8 over 24 plus, we can bring out this I, change this to 16 times 2 inside over 24. And then we know that if we reduce the first fraction, it's going to be -1/3. And then over here, it'll be 4i square root 2 over 24. And then 4 into 24 is 6. So we end up with -1/3 plus I square root 2 over 6. Okay? Factoring. Factoring is really important. So the first one is pretty simple. And the reason why you want to factor is to find the solutions to anything that is quadratic. So you can look at the example here. That one's pretty simple, so I'm going to go right past it. In order to solve for x with anything that's quadratic, you want to make sure everything is on one side and then set it equal to 0. So you had to move this one over, okay, so that you can factor this part. And then you just solve for x. So here you would do x squared minus 8x plus 15, set it equal to 0, then set up your factors. So x, two numbers multiplied together give me 15, but added together give me 8, which would be 3, and 5. And then you just set each one of those equal to 0. And you end up with x being equal to 3 and also 5. And if you don't believe me, you can go and look at Desmos. And you can type in what was on the left. So f of x equals x squared minus 5x. What was it? Plus 15. And if you zoom in, as long as we can find it, it's up there. No, that's 8x, Lord, not 5x. But if you zoom in, well, you can click. There's your solutions right there. So Desmos is a wonderful way of checking to make sure that you did your factors correctly and that you solved correctly. You can just look at the example there. These are two that are use the square root property to solve. So you just, you add 21 to both sides, and that is here. And then you divide both sides by 3. Now, because you have x squared equals something, you have to consider the plus and the minus. So just be careful with that. Same thing here, except that now, since you have minus 45, when you divide by 5, you still get a negative, right? You still get negative, it's negative 9. So you have to do the plus and minus of negative 9, and the square root of negative 9 is 3i. So plus or minus 3i. And then sometimes you end up with something that looks like, it looks a little crazy, but it's really just a decimal. They're a little bit more difficult to check when you look at, so if I graph this, it's not going to look nice and neat in terms of how you graph it. So I'm going to graph that. F of x equals to x plus 5. Oops. Of 5 squared. Okay, it was plus 11. So as you can see, it doesn't cross the x-axis, but where the zeros are not. It's some decimal. You just don't know where those solutions are. Because they don't necessarily cross the x-axis. And then they're asking you to find a term. This is kind of leading into the completing the square. It's probably my least favorite method. But you do it so that you can condense. So you see right here. So if I take half of the middle term, I'm going to get 3. So all you do is apply that here. So if I take half of 10, and then I square it, I'm going to get plus 25. So I can rewrite this as x minus 5 squared. All right, so if you see here, what you do is whatever you're given, you need to move the constant term to the other side, leave a space. So half of 4 is 2, and then 2 squared is 4. So that's why you write it here, but you also have to add it to the other side. Then you can condense it, and then you take the square root. That's how you solve this. So you take the square root. I mean, that's how you get rid of the square. So you take the square root of both sides, and then you just simplify down to where you get these two. So if I do the same thing here, x squared minus 6x, I'm going to leave a space, set it equal to 11, and then I'm going to add the same number that I get. So if I take half of 6, I get 3. So this would be 3 squared, but I need to also add 3 squared over here. So x squared minus 6x plus 9 equals 11 plus 9 is equal to 20. Then I can condense this. Take the square root of both sides. I'm going to get x minus 3 equals... So the square root of 20 is the square root of 4 times 5. So it ends up being 2 times the square root of 5. So 2 times the square root of 5. X is equal to, and it's plus or minus. So x equals 3 plus or minus 2 square root 5. So I kind of did it all in one step. You can practice this one. I would never give you one that looks like that on a test or anything, but you can practice the next one. And then there's another way of factoring called the quadratic formula. So when something's not easily factorable, we use the quadratic formula. So we're talking about an equation that is, or linear equation, quadratic equation that is in the standard form. And then you need to identify what A, B, and C is, and then you just substitute all the numbers in. So here, if you look, it's the coefficient of x squared is A, the coefficient of x is 2, which is the letter B here. And then the C is the constant term, which is -1. Just plug them all in. I'm trying to debate, do I want to show you on the calculator? I think I might as well. So I can show you just some simple functionality of also what Desmos can do. So you have to be careful though, because if you put it in Desmos and you don't put parentheses in the numerator, it's going to mess you up. And don't type x in there because that doesn't help you. So in parentheses, -2, we're going to do plus first, and then the square root of 2 squared, and then minus 4 times 2. Gotta find the times 2 times 1. And you can also use parentheses too. And then you go outside of the parentheses and then type a slash or a division. And then just type, and I like to put things in parentheses in the denominator too. It's not undefined. Where are we getting undefined from? Did I make a mistake? -2 plus 2 squared. Oh, it's -1. Oops. That's -1. There you go. So what you see on the document, you see here it says 0.36 is long decimal. That is what this is in decimal form. So that's why we use the quadratic formula. I recommend that you just write and practice both of these and then see if you come out with the answer on the last page. All right, so the determinant is to figure out what type of solutions you have. So sometimes you have one x-intercept, sometimes you have two, and sometimes you have none. So in this, let me go back here. So in this particular one, you see that it does not cross the x-axis. So it has no x-intercepts. So the solution is like just, it kind of like in outer space. But the determinant determines if you have one that is repeated. And it also determines what type of solution you get. So if you compute the discriminant and determine the number and type of solutions. Okay, so this one in particular, you just use the same thing as you did with the quadratic formula. The thing that I like to do is label my function A, B, and C. So I know what numbers go where. In a discriminant. So if the discriminant is 0, there is one repeated real rational solution. If the discriminant is positive and a perfect square, there are 2 rational solutions. And if the discriminant ends up being negative, there is no real solution. And there are imaginary solutions that are complex conjugates. So that's pretty simple. You can just practice that. It says, what is the most efficient method for solving a quadratic equation? And it is with the square root property. And then number 6. That's not it. That's not number 6. No, this is the wrong one. I grabbed the wrong one. And number 6 is the same. Number 6 is also the square root property. And then here's one where you have to use a quadratic formula. So you would just use A, B, and C. And then, it says use the function to find the age to the nearest year of a woman whose normal systolic blood pressure is 115. I have no idea what MM means. And neither do I know what HG means. But it's the blood pressure symbols. And then you just, you don't use the -1 because it's not real, it's not possible. Okay? So you can just practice doing the other one. And then I mean, this is polynomial, so you're doing the same thing. You're using factoring to solve. So use the same procedure. With 1B, you would need to, it's called factoring by grouping. So what they did here is they moved this side over to the left. So if you wanted to model what you see on the left, factoring by grouping means you need to factor out something that they have in common, and it needs the quantities that are left need to be the same exact thing. So you've got to be mindful of that. So you see that right here, it's 2x plus 3 and 2x plus 3. They have to be exactly the same. So x squared plus, not plus, x squared times x plus 2. So you should have the same thing over here, minus 4 times, oh my gosh, this is 3x. I gotta go back. So x squared times 3x plus 2 minus 4 times 3x plus 2. And then once you have those, x squared minus 4 equal to 0, and then 3x plus 2 equal to 0. So x squared equals 4. And then x over here is equal to negative 2/3. And this one would be x is equal to plus or minus 2. Yep. Okay, so I believe we did one like this in class. So you just have to, take into consideration, the method of multiplying an expression under a radical. So if you look at the example, when you get to figuring out your solutions, you need to also check your solution to see if it makes sense. And so if you see here, you get x equals 6 and x equals 1, but the solution set is only 6, because when you plug it back in, the 1 with 6 makes sense, but the one x equals 1 does not make sense. So for this side, 2x plus 13, when you square it, and then you square the other side, x plus 7 squared. So this will end up being 2x plus 13. And then this over here will end up being x squared plus 14x plus 49. And then just to put everything on one side, I'm going to move everything to the right. So we have x squared plus 12x. And then 13 minus, that'll be 36. So we end up with plus 36 equals 0. And then we end up trying to factor. So what is that? X plus 6 times x plus 6. Is that about right? And then so our x value equals negative 6. And then we plug that back in to see if that works. So we get the square root of 2 times negative 6 plus 13. And does that equal to negative 6 plus 7? So we get the square root of 1 here. And the square root of 1 is 1. And does that equal 1? And it's true. It does equal 1. Okay. And then just to challenge yourself, I would definitely write down all of this on this side and then do the same thing and just work out the problem. The answers are at the end. Again, these are in D2L. And then fractional exponents are a little bit tricky. You do the same process, but I don't believe that you have any fractional exponent with, anything other than the square root or maybe the cube root. So, you can practice those if you like. I will not test you on any of those. At least I don't believe so. And then for higher order, you do the same sort of process. So I would practice this on your own. So you see the example on one side and then try to do the same on the other side. I would not really bother with this. Even in calculus, we don't really do fractional exponentials when it comes to use substitution. So there's that. And then you have the absolute value. So pretty much what this means is, the absolute value, you have to consider both sides because we're talking about, the graph of an absolute value function is sort of like a parabola, but it looks like a V. Okay, so you rewrite it, meaning you just drop the absolute value symbols and you set it equal to what it already is, but then you also set it equal to the negative of that number, which is down here. So if I do this over here, it'll be x minus 2 equals 7, and then x minus 2 equals -7. And I think you can solve from there. And then that's how you end up with your solution set. Down here below, you are just, here it says, what annual income corresponds to 33.1 hours per week? So we're looking for the income. And you end up with, the annual income is in thousands of dollars. So when you get 225 down here, you just, include the 225,000. So for this one, it says, we're modeling a basketball player's hang time in seconds. So if the hang time is 1.16 seconds, what is the vertical distance of the jump? And T is the amount of time, but the D is the distance. So if the hang time is 1.16 seconds, we are going to solve for the letter D. So this will be 2 times 1.16, and then that's equal to the square root of D. And then we just square both sides to get rid of that radical. So 2 times 1.16, we'll square it, and that'll be equal to D. And that result would be, let me look for it. .4 feet. So if I take 2 times, let's just go to Desmos. I have other calculators on here, but we'll just use Desmos. So we have 2. Well, I can do 2 times 1.16. And then take that and multiply it, or square it. Sorry. I'm going to square. So I can put parentheses around it and then square it. And then you see it's approximately equal to 5.3824, which rounds to 5.4 feet. And then in this section, I kind of really think that the riddles in the beginning are funny. But here we are just talking about graphing. It says in set builder notation. So we know that the bracket represents the less than or greater than equal to, And then the parentheses represents just less than or greater than. So for this one, we're saying values, and I'm just going to plot 1 and then plot 6. And then, so the graph would be in between here. And then I think it's always easier to do the graph first and then the set builder notation, and I'm not artsy. So x such that 1 is less than x, which is less than or equal to 6. Okay. And then for the next one, you probably should just go ahead and try that one. And then for the next one, we use graphs to find each set. So we have the values, that are included with 1, 3. So we know that both sides will have a bracket. And then it's a union of 2, 6, but, it kind of overlaps. So what actually overlaps is 2 and 3, okay? And that way you can it's kind of like merging them together. So I would suggest you try one of those. You don't really have to do 2B. Some important things here, if you look at the example, you can work that out. But if I have negative 9x greater than or equal to 36, as you can see here, we start out with greater than, but we end up with less than. So when you multiply or divide by a negative, it flips the inequality. So x is less than or equal to -4. And then if x is less than or equal to -4, then we have a bracket with -infinity to -4. So our graph will be everything from the left up to the bracket and -4. Okay. Similarly with, equations, we need to, with rational functions, we need to find a common denominator, which is 4. So 4 divided by 4 is x. 4 divided by 2 is 3 times 2. And that's equal to the same thing over here, which is 2x. And then we multiply the 1 and the 4, which is 4. All of the fractions disappear. And we have x minus 6 equals 2x plus 4. And if I like to keep my x positive. So if I subtract x, I end up with x plus 4. And then I subtract 4. So I end up with x being equal to... I'm just realizing they don't have an inequality symbol over here. They just have equal. In any case, so x is equal to -10. I wonder if that's a little bit of a mistake because we're saying solve and graph it on the number line, but there is no inequality symbol there. I think that's a little bit of a typo. So a car can be rented for $260. It charges per week. It usually indicates multiplication plus 25 cents for each mile to rent. How many miles must be driven in a week to make the rental cost for basic rental a better deal than continental? So we're comparing two sides. So the cost for the basic rental is $260. Cost for Continental is $80, and they indicate that here. Continental is $80 per week plus 25 cents. So if we model that over here, an elevator has a maximum capacity of 3,000 pounds. If the elevator weighs 245 pounds, and each cement bag weighs 95 pounds, how many bags of cement can be safely lifted in the elevator in one trip? So 3,000 pounds is pretty much the limit. Okay, so you have to figure out, do you want less than, greater than, less than or equal to, or greater than or equal to? So if it weighs 245 pounds and each cement bag weighs 95 pounds, so that would be plus 95 and some factor. How many bags of cement can be safely lifted on the elevator trip? So this cannot exceed, so 3,000 is so greater than or equal to, that's what I would think. And then if we subtract 245, no idea how to do that in my head. So 3,000 minus 245, and that's 2755, and then we divide by 95. Hopefully it comes out even. So 2755. I don't think so, but we'll see. Oh, comes out even. So 29 bags. So what was that? 2755 is greater than or equal to 95x. Divide both sides by 95. So 29 bags is, so x must be less than or equal to 29. So x must be less than or equal to 29, which is at most. I encourage you to challenge yourself and do 4A, 4B, since you have the examples there, if you choose to do so, if you want to challenge yourself. Compound inequalities just means that you are solving something all at the same time. So if I add 1 here, I add 1, I get negative 10 is less than 2x, which is less than or equal to negative 4. And I just divide everything by 2. And you can just follow along with the example. So negative 5 is less than or, not less than or equal to, less than x, which is less than or equal to negative 2. And then if you were to write this, it would be, in the interval notation, it'd be 5. Negative 5, comma 2 with a bracket. Okay? With inequalities, it's a little bit different, but if you write them as compounded, then all you would do is just take this number and make it negative on the other side. So negative 8 is less than 2x minus 6, which is less than 8. And you see here they do the same thing. We just have to consider the negative side because it's absolute value. So, and you can solve from there. All right. And I think that's good for chapter 1. I recommend if you have any doubts about any of the types of problems, then you can use the solution manual that I posted on Google Classroom. It should match your book. If it doesn't, let me know. So thank you for watching. Please like and subscribe, and then you will see videos that I post in the future. Thank you for watching.